Good morning. We have another question. So today we're doing specialist maths, and I've been asked to do question 49. Sorry, on page 49, question 4D. Okay, so this is actually from the work on finding equations from graphs. So this is, oopsies. Yeah, graphing real polynomials. Okay. And we went through in class the different solutions that could occur in terms of different forms of factorization and what they mean as far as the intersection with the x-axis for cubics and also for quartics. All right. Most of the graphs you saw, such as these ones, you did not see any of these, by the looks of it, where there was an irreducible quadratic factor, but these questions do come up and we're just about to encounter one. So question 4D touches at the x-axis. All right, so let's just take this information. So we touch at x equals 1. That implies we have a factor of x minus 1 squared. Now we have a few other pieces of information. We know that custody of y-axis at 1, so we have other coordinate points. So it passes 0, 1, minus 1, minus 4, and 2, 15. All right. Now we know for an order 4 polynomial, which we're solving for a quartic, it's going to have 4 roots. Some of them repeated. So the idea of touching, this is actually a repeated root. So we're actually missing the other 2 roots. That leads me to think that I'm probably going to have an irreducible quadratic factor. But in any case, we're just going to have to assume that we might. So we're going to write the graph as such. Y equals x minus 1 squared ax squared plus bx plus c. All right, and then we're going to use the 3 coordinate points to solve for a, b, and c. Let's start by writing out some equations. All right, so if we have the coordinate of 0, 1, well, 1 equals, okay, a 0 squared plus b 0 plus c. Okay, 1 squared is just 1. These 2 cancel, and basically we have, is that right? Yeah, well, that is what it is. Yeah, 1 equals c. Sorry, so I know I've done this one before. No, I wrote that down wrong. That was 1 minus 1. Yes. Yep, I wrote that down wrong. Cut the x-axis and minus 1. Alright. So c equals minus 1, and I can just substitute that into the rest of them. So let's do the next one. Minus 1 and minus 4. Minus 4 equals minus 1 all squared. A, that's 1 squared, plus b times minus 1 plus c. So minus 4 equals minus 1 times, minus 1 minus 2, square that is 4. And we've got a minus b, and don't forget you already know what c is, so minus 1. Okay, I'm going to divide that by 4, why not? Minus 1 equals a minus b minus 1, add 1 to both sides, and add b across as well. Well, that's what it says. Okay. All right, looks like A equals B. All right, so let's use the last one. So if A equals B, then everywhere we see an A, we can see a B instead, or vice versa. Okay, there we go. Sorry, I realized didn't have that on the camera. All right, so now let's move on to 15. 15 equals 2 minus 1 squared. Okay, we got that. A2 squared plus B2 and C is minus 1. Okay. 4A, 2B minus 1. Bring that across, 16. And pretty sure I can group these up. That's A equals B. All right, if we group those up, 4A plus 2B, but as A equals B, 16 equals 6A. Divide that across. A equals 8 on 3. And then so does B. So then you can write your irreducible quadratic factor as such. Okay, so now the equation becomes this. Y equals x minus 1 8 on 3x squared plus 8 on 3x minus 1. And just to make things a little bit more nice, I'm going to take a third out the front. Let's make it 1/3 of x minus 1. X 8 x minus 1. Okay. Now, just for the purpose of checking that, now either I can go to my graphing package or I can use my calculator. So getting used to using our calculators again, let's go and do that. All right, so 1/3. Now I do, nope, it's not going to do what I want. All right, so oopsies. 1/3 bracket x minus 1 bracket 8x squared plus 8. What am I doing? All right, this is not working out. All right, I can't type it out. I'll do it. Press the buttons. Okay, so we're getting used to using these calculators on the computer rather. All right, so this emulator is not quite as efficient as I would like it to be, but all right, rather do that than just pull out Desmos again, because this is what you guys would use in a test. You won't have access to a laptop to do Desmos. Okay. All right, so, oh, silly me. There's a squared factor. All right, hopefully I can fix that. Can I? All right, now I think I have to do an, let's see. You have to rewrite the whole thing, that's fine. Where is the insert button? There it is. Alright, fingers crossed. Nope. I did it in the wrong spot as well. And I just deleted the whole thing. Alright, well, there might be more. I'm just going to be lazy and just do decimals. Okay. Is that one I can type out? Alright. See, I'm pretty comfortable in just typing that out with my keyboard. I just need to get more practice and get more savvy with the emulator, which I'll do another day, but I don't want to get this video to drag on for too long. So let's just wrap that up. Okay, so there is our quartic. So, all right, so yes, I'm pretty confident that you would have seen the touch here. We do actually have, this is actually not irreducible, but the roots would be surdic. So it isn't irreducible. You could actually factorize this into three linear factors because it has a repeated one. Now, I'm getting inclined that I might have made a mistake somewhere. Of course I did. That's why. There's a mistake in here. When I took out the third, I should have made that 3. That's a mistake. Let's fix that. That's better. Okay. That's now correct. Let's check the other points. -1 and 4 and 2 and 2 and 15. Ooh, so close. What have I done wrong then? I don't know. Something, there's an error in there somewhere. All right, but you get the general idea. That's the general strategy, how you go about doing that. And yep, that's this video. So you can by all means go and try it for yourself so you can find where my mistake was. All right, catch you later.